Hey y'all, ready for Vertex Form? Woo! This goes along with 2b, which is I can describe and use the parts of a parabola, but it's really just vertex form, so I just changed the word on this for that. Vertex form looks like this. Did we do this already? Yes, sure, we sure did. Or f of x sometimes. F of x is just y. Don't let algebra 1 scare you. We're going to use a lot of colors today because I'm going to color code everything, so you know, if you want, you can pause it and go grab these, but you do you. So we're going to graph one thing in vertex form. We're going to describe the transformation, and I'm going to show you where the vertex, axis of symmetry, and increasing and decreasing intervals are. That's what we're going to do. So I'm going to really quick draw a graph. Well, I'm going to do that first. Does it have to look exactly like this? No, it sure doesn't. Is it gonna? I don't know. You tell me. All right, so first of all, the vertex. The vertex is a point. It's the point HK. It's the top point or the bottom point. In this case, this 2 right here, it is the 2 that goes there. If it was positive, it would be negative. It's opposites. And this 7 right here is 7. So my vertex is the point 2, 7, which I can graph immediately. 2, 7. Beautiful. That's the vertex. That point right there is the vertex. The axis of symmetry is a new word, maybe. You technically learned it in Algebra 1. Do you remember it from 2 years ago through a pandemic? No. Would you remember it even if there wasn't a pandemic? Who knows? The axis of symmetry is always going to say x equals, and it has to go through the vertex. So it's x equals 2. It's that 2 right there. It's the same 2. Nothing's changed. The axis of symmetry is a line that goes straight down through the vertex, and it's called the axis of symmetry because the symmetry part is that the graph is the same on both sides. That's key right here. Everything on one side is going to be the same as everything on the other side. Cool. Now, let's talk about how to graph this -3 part. Okay, it's a vertical stretch of 3, and it's been flipped over. So I automatically know that my graph is going to go down. And I already know that it's going to be kind of stretched out. So it's going to be like nice and thin. That's what I know. But let's actually do it. So here's what I do. I take that beautiful 0, 0, 1, 1, 2, 4. Technically the next one's 3, 9, but whatever. And what I'm going to do is I'm going to take all the x's and keep them normal. But I'm going to multiply all the y's. I need to put away the colors that I haven't used yet. I think that's red. I'll use purple instead. I'm going to multiply all the y's times -3 because of that -3 up there. Y times -3. So what I get is not enough space. I get 0, 0. I get 1, -3. And I get 2, -12. That's how I stretch it out. Can you do it other ways? Absolutely. Can you use plots in the graph? Why not? But what that's going to say is that this is my vertex. So I'm going to start at vertex at 0, 0. And I'm going to go over 1 and down 3. Over 1. Over 1, down 3. That's my first point. I already said that everything is flipped over the axis of symmetry. So there's also a point on this side of it. It's symmetric. And then I can go from the vertex. I'm going to go over 2 and down 12. Oof. 1, 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Is that close enough? Sure. And then it's also on the opposite side, which will actually be on the y-axis. The y-axis. That was a weird way for me to say that. So then I actually get my graph. Look how good I did. Oh my goodness. Why is my pen dying right now? Because it's a jerk, that's why. Why did everything smear on the side of my paper? Same reason. Okay, so that is vertex and axis of symmetry. Just to recap, like we've kind of done this in Algebra 1, but if you forgot everything, I got you, don't worry. Okay, let's describe the transformation. Not new. This is not new. We did this. We've done this for 2 days now, the third day of this. The negative is a reflection or a flip. The x-axis. The -3, the 3 part is a vertical stretch of 3. The -2 moves to the right 2, and the +7 goes up 7. That's the transformation. I'm only doing this because it's been confusing on the check-ins. That's the only reason. Now, here's the crazy part that confuses everybody, and I'm willing to bet it's going to confuse you too, but I'm ready for this. Are you ready for this? I'm going to do some lighter colors. I lied earlier. Sorry. Okay. Now, I want to know the intervals of increasing and decreasing. Why didn't I pause this to write it? I don't know. I forgot I can do that. I probably do that a lot. So my increasing interval, I read the graph from left to right. Okay. So I start on the left side of my graph, and I notice that when I do that, my graph is going up. That's an increasing interval. It goes up all the way until I get to the vertex. Okay. Now, it's gonna be an interval, so it's gonna be x is something with the 2. Now, because it's all the way up until that 2, it's everything that's less than 2. Here's where 2 is, right? It's everything that's less than 2 is when it's increasing. Is that confusing to everybody? Absolutely. Is that okay? Yeah, we'll figure it out as we go. So when x is less than 2, it's increasing. That just means to the left of 2. Or of the vertex. Okay. Then I can't use this color because it'll confuse you more because it's yellow. You can't see yellow. You can, but you can't process it on this. Now I continue left to right, and I notice that my graph is going down. You see that? So left to right, that's where it's decreasing. It's decreasing all the way after my vertex. And so that means it's decreasing when x is more than my vertex or to the right of the vertex. Now here's the thing. This 2 is not a coincidence. It's been a 2 the whole time. It hasn't changed. It's still from this -2 up here. I made it opposite. Or as my last year's kids would say, or 2 years ago, would flip that boyo. I don't suppose they will ever watch this, but I still remember that. So opposites here. Still here. It's still here. It's the same number the whole time. It has not changed. It's also here. The 2, it's like a conspiracy theory. Now, the things that will change that you actually have to figure out are these inequalities. There's going to be one of each. There's going to be a less than, there's going to be a greater than. But you're going to have to figure out which one's which, depending on if the graph is like this or if the graph is like this. So in this case, I went up. It was increasing until the vertex, and then it was decreasing after. Increasing until the vertex, decreasing after. I have you in your, if you do the Desmos activity, I have you kind of like highlight where it's increasing, and then you can write it in there. I should probably switch it so it's upside down because it's going to be opposite of my notes that way. I don't know. And then because I did it, here's the 7 is still here. Here's the 3. And then the negative is what flipped it over. Those numbers aren't mistakes. Gosh, I hope that helped. If you have any questions, or if Algebra 1 was just too far away and you need more examples, please tell me. I'm more than happy to make more examples for you. I have an entire notebook for more examples, but nobody's asked me yet, so I haven't busted into it. So I'm not going to do it for fun. I know how to graph these things. It's for you. All right, so let me know if you need it. And otherwise, I'll see you in class, I don't know, Tuesday, probably. I don't know which day it is that I'm posting this. Okay, bye.